Uh, Good afternoon, everyone. My name is Chawisa Thangjittiporn. I'm from Geriatric Dentistry and Special Care Faculty of Dentistry, Chulalongkorn University. My advisor is Assistant Professor Dr. Ansri Vacharasa, and my co-advisor is Associate Professor Solapat Hemlanglod. Today, I would like to present my study, the test of chewing efficiency by the two-color gum mixing ability and the ViewGum software. The glossary of prosthodontics defines the chewing efficiency as the effort required achieving a standard degree of comminution of food. Chewing is the first process in digestive system, which is important for maintenance of nutritional status and quality of life. Therefore, the chewing efficiency reflects the masticatory function. It can be assessed for access of dental treatment or detection of masticatory function problem. Assessment of chewing efficiency can be measured objectively, subjectively, or by combination of both. The subjective assessment can be evaluated by questionnaire or personal interview. Objective assessment can use objective tests or masticatory tests. However, no positive correlation was found between subjective and objective measurement. Therefore, the self-assessment of chewing efficiency might be insufficient for evaluation. Many objective methods have been developed to assess chewing efficiency. Firstly, I will talk about sniffing method. Sniffing method is an objective test that we consider as gold standard method for clinical and experimental purposes that was reported to be highly repeatable with validity and reliability. However, this method requires special equipment and presents some inconvenience and time consuming. Another objective method is a measurement of color change in the chewing gum. This method has been developed by a Japanese research group to measure masticatory performance from the color chain of the chewing gum. The material method was specially developed use a color scale or handheld calorimeter to evaluate chewing efficiency. It makes the test more practical. However, it's not easy to buy this chewing gum in Thailand. Another one is a two-color chewing gum mixing ability test. The two-color chewing gum mixing ability test. This method assesses the degree blending of the two-color chewing gum as an indicator of chewing efficiency. This test significantly correlates with chewing tests. It provides simple and safe evaluation. This was recommended as a suitable method for subjects with impaired mastication. The degree of mixing can be evaluated either visual on reference scale or optoelectronic assessment. However, visual assessment appears to be less reliable than optoelectronic assessment. The optoelectronic assessment can be used by several software such as Mathematica, Adobe Photoshop software, or the ViewGum software. In this study, we use the ViewGum software for evaluation chewing efficiency with the reason that we will explain in the next slide. The ViewGum software is reliable and accurate to be used for optoelectronic assessment of the two-color mixing ability. This method was originally described by Harisonetis et al. 2013. This software is a freeware and can be easily accessed from any clinical setting or laboratory. The software scans the image of both sides, then variant of hue will be calculated by the software. The variant of hue is considered as measure of the mixing. A high variant of hue results from poorly mixed color, whereas a low variant of hue shows well mixed color. and many study using the two-color chewing gum test with the ViewGum software to analyze chewing efficiency. Nowadays, smartphone is a common device that's carried by people at all times. Many applications are useful for healthcare purposes. Therefore, in this study, we apply image captured by smartphone to simplify the previous protocol of the two-color mixing ability test before using the ViewGum software for analysis of chewing efficiency. The objective of each study is to determine the reliability of the digital image of the two-color chewing gum taken by smartphone in comparison with the image scanned by the scanner for the chewing efficiency analysis by the ViewGum software. Material and method. The dental students and staff of the Faculty of Dentistry, Chulalongkorn University were recruited for oral examination by one researcher. The subjects who were healthy, full dentate, and angle classification 1 occlusion were included in this study. The research was approved by Ethics Committee at the Faculty of Dentistry, Chulalongkorn University. Hubba Bubba tape gum in flavor strawberry and fancy food were used for color mixing ability test. The gum were prepared according to the original protocol. The gum were cut from both and manual stuck together before chewing test. The participants were instructed to chew on the prepared two-color chewing gum at a steady rate for 20 seconds. Then both sides of specimen were scanned with the scanner and photographed with the smartphone to obtain the digital image for analysis by ViewGum software. A flash scanner and smartphone were used to capture the image by the ViewGum software. This software measures a change of standard deviation of the hue component in gum image. Therefore, less variation in color hue implies higher mixing. Interclass correlation coefficient was used to determine an agreement of image recorded by the smartphone and the scanner. Pearson correlation was used to investigate the relationship between the variant of hue analyzed by the ViewGum software from scanner image and smartphone image. The result of this study: 21 healthy participants were included based on the inclusion criteria. The mean age was 29 years old. This is an example of the chewing gum image. After chewing test, figure A was scanned by scanner and B taken by the smartphone camera. The digital image from both methods were accessed by using ViewGum software. The ViewGum software analyzes variant of hue from chewing gum image for chewing efficiency. The table shows the mean variant of hue from scanner image and smartphone image, and the mean chewing cycle number of all participants. The similarity of detection when using image from a scanner or a smartphone. The variance of hue was analyzed by the ViewGum software, and they demonstrate that variance of hue of image from a scanner was similar to that of the image from a smartphone in the same participant. The interclass correlation coefficient between variant of hue from scanner and smartphone image indicate good reliability between both measurements. After that, there was highly significant positive correlation between the variant of hue from scanner and smartphone image, analyzed by Pearson correlation. The scatter plot shows strong correlation between the variant of hue from scanner image and smartphone image analyzed by ViewGum software. The discussion. The chewing test was modified from the the original method. The previous study comment in the use of a scanner image followed by a computer analysis that the process was too complicated for routine use. Therefore, the use of smartphone to capture digital image was added to simplify the method in this study and aim to make the process technically practical. We found that the use of smartphone to capture image of a chewing gum after chewing taste was highly correlated with the image scanned from the scanner. The chewing gum sample were imaged immediately after taste to minimize a bias from material color cell chain. Actually, there were many studies using the other software for digital process assessment, for example, Mathematica software or Adobe Photoshop software. They show their reliability on assessment of degree of color mix of the two color chewing gum in previous study. However, there are some limitations such as it time consuming, unrealistic in clinical setting or complicated calculation. This study used the ViewGum software because it has been proven to be reliable and discriminative tool to optoelectronically for evaluation of chewing efficiency with the two-color chewing gum. And many studies using the two-color chewing gum test with the ViewGum software to analyze chewing efficiency. Many health factors affect chewing efficiency, such as tooth loss, improper restoration of occlusal contact area, or oral motor function. Therefore, the analysis of chewing efficiency is not only useful to follow up the improvement after dental treatment, but also to detect a decrease of chewing efficiency, which could be a good indicator for overall health decline, such as malnutrition, dysfunction of muscular system. It may detect the problem leading to diagnosis or proper treatment. In conclusion, the two-color chewing gum test can be used to analyze the chewing efficiency through ViewGum software. Digital image taken from the smartphone is simple and quick to proceed with the two-color mixing ability test. The results from this study provide a simplified approach to assess chewing efficiency. The evaluation of chewing efficiency will provide information for diagnosis in patients with chewing deficiency and determine the success of oral rehabilitation during dental treatment or in follow-up visit. And thank you for your attention.
Very interesting research. While waiting for question from participant, any question from our participant? During waiting, may I ask you, the presenter, Dr. Chawisa?
Okay.
From your nice presentation, I wonder, your subject, the age range of your subject vary from 18 to 50, and there are 14 female, but only 7 males, right? How about your comment about age and sex of the subjects in your research? Is there any influence on your result or not?
You mean
because,
about it?
First, I noticed that from your result analysis,
Okay.
you use correlation to show the correlation about variance of hue between scanner image and smartphone image, right?
Yes.
But you use Pearson correlation, right? It means that you haven't controlled for any confounding factor, right?
Yes, I try to control confounding.
Yes, so I wonder, I would like to ask about your comment about age and sex of the subjects in your research. That is there any influence on your result or not?
You mean I control the confounding factor from the criteria?
Yes, right. Because you control the seismic disease, the anchor classification, the factor that you think to influence the showing efficiency, right? But
Yes.
there are some variation in age and sex of the subject in your research. It varies from 18 to 50, and just only 7 males but 14 females. So how about your comment about the factor of age and sex for your result?
For the age, for the sex, I think this is a limit. I cannot control the sex for my research, but in the age of subject, because I use a subject in limit in the faculty in dentistry, so the age that I control it, the lens. You mean the lens is wide, right?
Yes, I understand it's very difficult to include all participants to join your research. So if there is, first of all, you think that age and sex affect the showing efficiency or not?
I think the age may be affecting efficiency, but in the age in the previous study that I review show the age. The patient that have chewing that have problem in chewing have the age more than 60 or the are called the elderly. But
Yes.
in the lens rate with the healthy, I think it's not, I show the chewing is normal.
So I think it is better if you try using partial correlation. It means that you can use the old data, but you can try, maybe in my opinion, you can try partial correlation instead of Pearson correlation in order that you can control age and sex in your correlation analysis, or whether if the best statistic method to compare the two techniques in the same person, if the technique each one of the other technique is not the gold standard, right? You just want to compare between two techniques. You can use a bland Altman plot. Bland Altman plot is this statistic is to investigate whether these two techniques is different or not, because your objective, you want to search for which technique is better, right?
Yes.
Because there is no gold standard or no gold standard technique for this showing efficiency evaluation, right? So please try another statistical analysis. It maybe shows something improvement, or you can more analyze in some detail. But I think it's just only my comment for your interesting research.
Thank you for your opinion.
Is there any question from audience? We will still some a little bit, a few more minutes. So may I ask some more one question?
Yes.
Is there any difference or any influence from specification of smartphone or scanner to affect the quality of photo that taken before use the software or not?
I I think may be effect if they have more different in the resolution of the camera or the scanner. In this study, we use the scanner, the same solution with the original method, and the smartphone. I try to control the same light or the distance to have the less effect from envelopment.
Yes, so because it's very interesting investigation and interesting method to use for general dentists to use for evaluate showing efficiency, right? So if you have any recommendation about the minimum pixel of smartphone or not that general dentists have to use how to say some minimum specification of smartphone, how many pixels, something like that. Because I'm in low technology, so I want to use this technique to evaluate my patient, how I can use.
I think in this study we use the iPhone 7.
Yes, right.
And they have the resolution of the 12 megapixel. So if you will try the smartphone, I think it should more than 12 megapixel.
Yes. So it means that not in trend maybe iPhone 7 maybe 3 or 4 years ago, something like that, it can be used, right? So thank you very much for your nice presentation,